Hello, I want to make sure that you can do this worksheet in 15 minutes or less because that's how much time you'll be given. It says no notes. Hopefully you've practiced these before coming to see me to earn these extra credit points. Number 1 from exam 3, A, number the carbons on the alkyl halide. Some students were still having difficulty identifying what an alkyl halide is. It's basically a hydrocarbon with a halogen. And here it says to number it. I'll number it from the carbon connected to the halogen. 1, 2, 3, 4, and 5. Look where I put the dot. And so it says number those same carbons with the same numbers on the product. The alkyne attacked this dot, and I labeled that as number 1. And if I just follow the longest chain, 1, 2, 3, 4, the 5 is the methyl group off of carbon number 2. I think that's the correct numbering because this carbon here is this carbon here, and there was a new carbon-carbon bond made. The carbon-carbon bond was made during an alkylation of a terminal alkyne. Letter C says draw the mechanism. You do have to draw the letter H because we are going to deprotonate that alkyne. You got to start your arrows from a source of electrons. People were forgetting the lone pair on the hydride because that's the source of electrons, grabbing that proton, leaving behind a lone pair. Now our alkyne is an anion. You don't have to draw the letter C, but I think it just makes it easier for me to locate where the lone pair is if I draw the letter C. We did create H2 gas. The more important part is now that carbon of the alkyne is nucleophilic when you provided a primary alkyl halide. And so, keeping the color code consistent, there's your purple dot. Here's your chlorine. Okay. I saw some weird answers for this fill in the product because people were attacking or attaching the alkyne to this carbon, and they kept the chlorine. You're supposed to attack the carbon that has the chlorine because the chlorine is pulling electrons away, making that bond weaker. So again, the chlorine is pulling electrons away from the purple dot to make this bond weaker. That's where the natural connection would be. Your final product, I'll put the letter C again, is the alkyne carbon connected to the purple dot, carbon number 1, carbon number 2, 3, 4, and 5. We did create a Cl-, I think. That is the full mechanism for this alkylation. You could do that, then you will get plus 3 points on your practice set 3. Okay. Number 2, a couple of students have already come to do this worksheet, and they made models. So let's say, I don't know, maybe it takes 3 minutes to make this model. You've made alkynes before in lab, so that shouldn't be too hard. And when you look at the bond angle from I, this is your central carbon, there's actually 4 bonds. You know what 4 bonds makes? 4 bonds on a carbon makes a tetrahedral carbon. And you know the angle for the tetrahedral carbon is 109.5. 109.5 degrees. And so why were people putting 320, or sorry, 120? People were putting 120 because when you draw it, you draw it like that, okay? Even if it was tertiary, you would draw it like this, right? With a 120 degree angle. But that's on paper, right? In real life, you have something like this, where you have a dash and wedge. That angle again is 109.5 degrees. You'll know this as tetrahedral. Now on paper, 120 and 109.5, it just depends how many lines you have. I like, by the way, drawing when you have 3 bonds, get them as far apart as possible. So that is 120, but you have to realize there's a 4th bond that makes that carbon tetrahedral. If you do that, okay, with the model, you will get +2. Final exam. We're trying to build up extra credit for the final exam, so we're not, rushing at the end of the semester trying to find extra credit. If you're keeping score, this would be the 3rd and 4th extra credit point for the final exam. Our first 2 were a couple weeks ago. I can't remember the assignment, but most of you got those 2 points for your final exam a couple weeks ago. Okay, next, from exam 3, draw the mechanism. Okay, on exam 3, you did not have this exactly. You had this, where one elimination had already happened. I think I gave you NaH, but whether it's NaNH2 or NaH, you have a strong base. And people knew they had to get rid of the bromine from the final product. But people were removing, I don't know what they were doing actually. They should have been removing a hydrogen, and it should have been the hydrogen on this carbon here, the beta carbon. People did not realize that you were doing a beta hydrogen elimination. Okay. Which hydrogen do I want to remove? Let me do one of these. And now we have a base. And we remove this beta hydrogen to remove this bromine. So my alpha beta are actually here. Whoops. And here. That takes care of one removal of H and Br. And we have this. Now this is the one that was on your exam. I'm not going to worry about this blue hydrogen. I got to worry about the beta. The beta is here. Because we have a new alpha. If I want to get rid of this bromine, the alpha carbon is there, the beta carbon is there. By the way, on the first step, we created NH3. For the second elimination, remember this is double beta hydrogen elimination. We are getting rid of that. Collapse, kick out. Are we done? We're not quite done yet because we noticed that in the product, it's a C minus. Right now we have a CH. And you know what color that H is? It's the light blue one. And therefore, we're going to use another molecule of NH2 minus. By the way, in the previous step, we created NH3 plus the Br minus. Same thing for the first step, plus Br minus. All right, we do a deprotonation, and that's how you get the anion without really adding anything else. It's all done with NH2 minus, the elimination, the double elimination, and the deprotonation. If you don't want to put the letter C, just be very clear where your charge is. It's on the last carbon. We did create NH3, and that completes the mechanism. This is good if you're able to do this, because now we can start adding points to your practice set 4. And this is worth 3 points. Oh boy. Okay, we're almost there. Next, I did not get a chance. I really wanted to give you a chance to show that you know the difference between Markovnikov and non-Markovnikov. Because each carbon of the double bond gets something. We learned this reaction, Markovnikov, quite a while ago. But we actually learned this reaction to make this product fairly recently, because it's a radical mechanism, and this was non-Markovnikov. The reaction that you learned quite a while ago, HBr, it goes on the more substituted carbon, the Br. But if we wanted to go on the less substituted carbon, it's HBr with added peroxide. And so we did not learn these reactions together because the mechanisms were very different. One was an addition reaction, right? Add to the double bond. Or, let's really differentiate this. Electrophilic addition. We added an electrophile. Whereas this is an addition also, but it's a radical addition. And we learned it with the other radical reactions. If you want to add points to your actual exam 3, do problem 4. And let me look at your exam, because I think I could find a point to give you back on your exam 3. Okay, that will be a total of 2 points added to your exam 3 if you could do those 2 things.